So we're going to continue on with our excretion topic. So this was our homework question. It asked you to describe an animal who is dependent on its external environment. That's lizard. It asked you what was the term to describe maintaining a constant internal environment. That is homeostasis. An organ is your skin. The term for an organism that uses its own metabolism to regulate its body temperature is endotherm, and a rabbit is an example of an endotherm. So pause this now for yourselves and see, can you work out what each of these two diagrams mean, and could you put in some labels? And then when you're ready to go, restart. So 1 is your sebaceous gland, 2 is a hair, 3 is an erector muscle, makes your hair move up and down, 4 is a sweat pore, 5 and 7 are both receptors. Because 5 is further down, it is a temperature receptor, which makes 7 a sense receptor. 6, because we're at the squiggly part, is going to be the sweat gland. If it had been at this part of it, I would have said that's the sweat duct. Down here then, number 9, we have our adipose cells, or adipose layers. The fat cells is an alternative name. And 8 here is our hair follicle. So up here, this little seesaw type scenario in my head says to me homeostasis, maintenance of a constant internal environment, so it has to be the same. And this guy up here is an example of an ectotherm, so an organism that maintains its internal temperature on the basis of its external environment. So it'll gain or lose heat from the atmosphere. So today we're going to link the parts of the skin to the different functions of the skin. Before we do that though, on page 181, we're just going to complete some of the bits here. So in this, we said we had 3 layers of skin the last day. This bottom layer is the Malpighian layer, and it produces a chemical called melanin. And the photo here may give you an understanding of what melanin is or what melanin does. So melanin, for starters, is a brown or black colored pigment, and its main job is to protect skin against harmful UV rays. So we don't really have any redheads in our room now that Artie is gone, but people with red hair usually have very, very pale skin. They have very, very little melanin. When they don't really tan, but they will burn, and that's showing you the UV damage. We now in Ireland have loads of people that are of African origin, so they will now have lots and lots of melanin production. Their skin won't ever really burn, and they're able to protect themselves against UV better than people that are redheaded or Caucasian. And even on that scale, all of us in the room, we will all tan to different degrees depending on how much melanin we have. So some of us will tan better than others, and actually tan while we all look lovely in it, it is not really a good thing, because it means you're trying to protect your skin against sun damage. So the next thing then we're just going to say, just in terms of our inner dermis, it has a thing called connective tissue, and we looked at that when we did chapter 8, where we talked about the different types of cells, or tissue types, and organs and organ systems. So the protein in there is called collagen. So as we age, our collagen gets less and less weak, which is why skin seems to sag as you get older. Just in terms of then the little things in our skin to remind ourselves, we have our sweat glands, we have our sebaceous glands, we have our hair follicles, we have our nerve receptors, we have blood vessels in our skin. The last little bit kind of new information before we get to the new learning is below these layers we call it subcutaneous. So below the epidermis, and even it's in the dermis, but below the layers that have all of the sensors, we have your subcutaneous layer, and this is where we find our adipose tissue. So it's the yellow parts down here in this diagram. So you will have sometimes when you go to your GP, they will give you a subcutaneous injection, and what they do is they pinch your skin, and when they do that, they're able to inject directly into this fat layer over here. When we finally all hopefully it will happen, we will get our mRNA vaccine. That goes into the muscle, so they will literally just stab us all, but it will go through the epidermis and the dermis layer to put that mRNA directly into our muscle cells. Okay, so if we had been in lesson, we would be splitting you up now, and we would be asking you four ways that skin protects us. What is the role the skin plays in vitamin production and food storage? What does it sense? How does it work as an excretory organ? And what does it do in temperature regulation? But we're not, so we don't get to pick our hats out of our name out of a hat. Instead, we're just going to go into it. So this is the top of page 182, and you have, a little table. So we have our protective functions, and now what are the parts that do it? So our epidermis, in terms of our protective job, it's a barrier to prevent loss of water. So this is the keratin that we talked about the last day, that's made in layer 2 in the granular layer. And it prevents entry of pathogens, and pathogens are disease-causing organisms. So bacteria, fungi, amoeba, you don't want them getting into your blood, essentially. So skin is the first barrier that they come up against. The dermis itself, in terms of its protective function, the fact that it's so big, it will protect the your internal organs from being damaged. We then have melanin, which we've talked about, so that protects the skin from the UV rays. And we have the sebum. So sebum is the stuff that's secreted in your sebaceous glands, and it is going to keep your hair moist, and it prevents your skin from drying out. So in reality, for those of us that have really oily skin, our skin actually ages better. We get less wrinkles. We still get them, but we get less of them. Whereas if you have very dry skin, your skin actually ages an awful lot quicker. So embrace spots during puberty, because in the long term, it's going to be good. So there are the protective functions of the skin. In terms of unfortunately, that is not your lesson over, unlucky. So in terms of vitamin production, then the vitamin that's produced in skin, I'm hoping that you know it, is vitamin D. And if you don't have enough vitamin D, you will have issues with calcium absorption. So because now parents are told to factor up their small kids at SPF 50, what you find is these kids present with rickets. These bow legs is what it looks like. And the reason that is that they are not getting enough vitamin D, whether in their diet or from the sunshine. And we will do this when we do food biomolecules. So while we should factor up, if you're not getting enough vitamin D in your diet, you need to let your skin absorb some sunlight for a little while, and that will help you in your calcium absorption. So that's the vitamin production part. Our skin is a food store, while this adipose tissue in the bottom of the dermis and the subcutaneous layer, that acts as a food store. So God forbid we had no access to food, you would be able to use the fat in that layer as an energy source. So then, as a sense organs, you should know the two senses that our skin will be able to use its receptors for, and that is touch and temperature. And then as excretion, we've done this already, it is our sweat glands, which are responsible for removing of sweat. We've said sweat contains water and salts, and sweat is removing these metabolic waste products. So sweating is a good thing. Now the last part of this is the part that's probably more commonly asked. Now this won't work for me, but you have to think about what happens on a hot day versus what happens on a cold day. So we're in winter now. Cold day, what's going to happen? So I'm just going to draw a new hair follicle over here. So if it is a cold day, if it's a cold day, your hair is going to stand upright, and what you find is you get little goosebumps, and what those goosebumps are is essentially you're feeling all those erector muscles are going upright, and you will also, I hope, know that you start to shiver. So that is your muscles contracting and relaxing, and there's a reason for doing that. Your skin goes paler, so your blood vessels go deeper into your skin, they get smaller, whereas on a hot day, the hair will actually flatten. Your blood vessels would actually get larger, they'll dilate, you'll see them more, and that's such that they can give off their heat through the skin. So while this animation won't work properly for me, hopefully we can draw a little diagram here and we'll figure some stuff out. So I'm giving you some of the keywords that an examiner would look for. So during your cold, your hair stands up. There is a word to describe that. It's called piloerection. So if you just use that word, so during cold conditions, piloerection happens, you will get your tick. But you can say your hair stands up on your skin. And the reason that happens is because we want to trap the air, any type of air. It's going to be warmer than your body. You're trapping that to your skin, and that's a good thing. The second word we use is that vasoconstriction happens, and what that means is vaso stands kind of for vessel, and constrict means to get smaller. So the blood vessels in our skin actually get smaller, and by doing that, they are able to reduce their heat loss. And then finally, you shiver. So you could get maximum marks by just using these three words for yourself. So piloerection, vasoconstriction, and shivering. And the reason we shiver is because that makes our respiration have to happen quicker, and therefore our body temperature will go up because of that. Because once we're respiring, we're generating more heat. So those three words are really, really important. Now I've put this last one in because it goes with the endocrine system, which is going to be our last topic of the year. So there will also be increased thyroxine. It's a hormone. And once we make that, we increase respiration and metabolism. And when we increase respiration, we make more heat. So 1, 2, and 3 are piloerection, vasoconstriction, and shivering. And we've put in this little link to our endocrine topic, which we will do in due course. Okay, so if you want to draw a little diagram for yourself, you would have your little hair. Your hair is now going to be going upward. So that's our epidermis layer. You will have your erector muscle here, and we will be making really small blood cells down at the bottom. So we can't do the shivering unless you want to like do this to kind of say shake, 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 shake. Okay. So then, during warm conditions, what happens? Firstly, we sweat, which is great, and what that does is when the water is on the surface of our skin, it'll evaporate, and evaporating cools down your body. And obviously, because you sweat more, you need to maintain your fluid balance. So something like Lucozade has the right mix of water and salts that you need to keep you hydrated. The blood vessels will dilate. So now your skin will become more red, and the fact dilate just means they get bigger, and the fact that they're bigger means that it's easier for them to lose their heat, so they've got a bigger surface area to do that. And the last bit, and I don't know why it didn't come up, is the hairs lie flat. So now these flat hairs, they can't trap air, so we're not keeping ourselves not trying to make ourselves warm. So if we were to do our diagram again, this is now our epidermis. The hair is flat, so the erector muscle is here. This is our little hair follicle, and actually now if we were drawing our blood vessels, we would be drawing them way, way bigger, because we now want them to lose their heat. And if we draw a little sweat pore over here, you can draw little drops coming out of our little sweat pore, and we just do the gland part at the bottom. Okay, so production of sweat. This word here, you can use vasodilation to describe it if you so wish. So we had vasoconstriction in the cold, we have vasodilation when it's wet, and we have our hairs lie flat. So that brings us to the different end of the different functions of skin.